Bismillahirrahmanirrahim. Today our topic is measure of dispersion, in which we study standard deviation and variance. Student, it is more informative and you will learn more from it. Keep watching it. Calculate the standard deviation and variance of following data. Serial number 1, 39, 2, 35, 3, 40, 4, 45, 5, 55, 6, 57, 7, 57, 8, 58, 9, 61. These data are given, and now we have to calculate the variance and standard deviation. First of all, we study what is variance and standard deviation. The variance of The variance of a set of observation is defined as the mean of the square of deviation for all the observation from their mean. When it is calculated from the entire population, the variance is called the population variance, traditionally denoted by sigma square. Sigma is the Greek lowercase sigma. If instead the data from the sample are used to calculate the variance, it is referred to as the sample variance and is denoted by S square. In order to distinguish between the two, the symbolical definition for variance is. Now we here study the variance about sample data. The formula is S square is equal to summation into xi minus x bar all का square divided by small n for sample data, and sigma square is equal to summation into xi minus mu all का square divided by capital N for population data. And the second is standard deviation. Standard deviation S is equal to summation x into xi minus x bar whole का square divided by n whole का under root. We take whole the under root of whole for sample data, and for population sigma is equal to summation into x minus x bar whole का minus mu whole का square divided by capital N for population. These are the formula with the help of which we will solve this question. Now we can easily understood the positive square root of variance is called standard deviation. Now we move toward the solution of this question. Now here we draw a table to explain and calculate the variance and standard deviation. Here we draw some column to represent the given value. In this way, we can easily calculate the required data for the xi minus x bar, and fourth is xi minus x bar का square. Now we draw lines for table. We make some column. We draw first column, second column, third column and 4. Here we draw the 4 column to represent the required data. Now these 4 columns we draw a line. These 4 columns are drawn for representation of data column. First one column which is first one column drawn for the serial number. Second column serial number to represent which are started from 1 to third column 9. 1, 2, xi, 3, 4, minus 5, 6, 7, 8 and 9. And fourth column which represent xi minus 6 and bar under this table square. We also draw another line to show the summation of data written above the column. Now second column which show the different values of x. First value 34, 35, 40, 45, 55, 56, 57, 58 and last one is 61. Now we write the sample of summation in the last of serial number. Now we take the summation of x value, mean 34 plus 35 plus 40, 45, 55 plus 56 plus 57 plus 58 plus 61. When we sum up all of these values, then we get the summation which is 441. That's mean summation of x. Now first thing or the first calculation which we have to do is to find the arithmetic mean or calculation of arithmetic mean. It is ungrouped data. The arithmetic mean of ungrouped data is very easy to calculate. Arithmetic mean which is always represented by x bar. X bar is equal to summation of xi by n. It is the formula of arithmetic mean. Summation of x divided by n, n mean number of observation. Here the number of observation is 9. We here divide the sum of x value by the number of observation. It means 441 divided by 9 and we get the answer which is 49. Its mean, our arithmetic mean which we have calculated now is 49. Now third column represent xi minus x bar. It means that we here have to deduct all the uh, deduct the arithmetic mean from all of the values of x. First 34 minus 49. 49 is our arithmetic mean and 34 is x1. x2 35 minus 49, which answer is 11 minus 11 minus 14. 40 minus 49 is equal to minus 9. 45 minus 49, which answer is minus 4. 55 minus 49, here answer is 6. 56 minus 49 is equal to 7. x7 57 minus 49 is equal to 8. 58 minus 49 is equal to 9. 61 minus 49 is equal to 12. Now here we have no need to take the summation of xi minus x bar. We move towards the next column, which show xi minus x bar whole ka square. So here we take the square of minus 15, which is answer is 225. The negative, if the negative value multiply with same with negative value, then it become positive. Two negative values, the product of two negative value become positive. Minus 14 square is equal to 196. Then square of minus 9 is equal to 81. The square of minus 4 is equal to 16. The square of 6 is equal to 36. And the square of 7 is equal to 49. The square of 8 is equal to 64. The square of 9 is equal to 81. The square of 12 is equal to 144. Now at the end we have the need of summation of x minus x bar whole ka square. So we take the sum of all these values. 225 plus 196 plus 81 plus 16 plus 36 plus 49 plus 64 plus 84 plus 144. After adding up all of these values, we get the answer After that, our next step will be to write these values into formula. The sum of x minus x bar square is 8 92. Now first we have already calculated the arithmetic mean, which is 49, and now we move towards the solution of our question, which is first of all to calculate the variance. The formula of variance is summation into xi minus x bar whole ka square divided by n. So here we have already calculated summation of f into xi, summation of xi minus x bar whole ka square divided by n. Summation of xi minus x bar ka square is 892 divided by n, that is the number of observation, which is 9. So we divide the 892 by the 9, and in this way we get the value of variance, which is 94.11, 99.11. That is our answer. Now after solution of variance, we move toward the standard deviation. Standard deviation, as we have already discussed, that is the positive root of variance. So here under roots summation into x I minus x bar whole square divided by n, that is the formula of standard deviation. Now we put the values in the formula. Summation xi minus x bar whole square, the value is 892 by n, that is 9 ka 9. It means the answer is 99.11. So if we take the under root of 99.11, then we get the answer of standard deviation, that is 9.955. That is standard deviation. Now we have written all these values in the columns, and we have already, first of all, we have already write and discuss the formulas of variance and standard deviation. For sample data, we have write the data in the column one by one. Serial number xi minus x bar, xi minus x bar whole square, and with the help of these data we first of all calculate arithmetic mean, then xi minus x bar, and then xi minus x bar whole square. Arithmetic mean, which is 49. Now after calculating all these values, we put all these values in the formulas. First of all in variance, and second we put all the values in standard deviation. Here only just difference between variance and standard deviation is we take the under roots of the variance positive under root, that's called standard deviation. Standard deviation, which is most common and most popular measure of dispersion, which is used to here the question is given, that is calculate standard deviation and variance for group data. B also calculate coefficient of variation from following data. The three things which are asked to calculate, first one is standard deviation, second variance, and third variation, coefficient of variation for group data. The data which is given for calculation is x, f, x and f. X, that is mid value, are the observation 5, 15, 25, 35 and 45. Their corresponding values are 10, 25, 30, 20 and 50. 15. Things, the formula which we have, the needs are number 1, arithmetic mean x bar is equal to summation fi xi or fx divided by summation frn, that is arithmetic mean. Number 2, the formula of variance is equal to summation fi or f into xi minus x bar whole का square divided by n, and here is summation f or sum of the frequency is n. Number 3 formula which is necessary and is of the standard deviation, standard deviation, which is the positive and positive roots of the variance. Here we write all these formula, summation f under root of summation fi xi into xi minus x bar का square divided by n, and the third, the formula for standard deviation under root of summation fi into xi minus x bar का square divided by n, its mean the root of variance, positive root of variance, is called standard deviation. Now we move toward the third formula, which is coefficient of variation of variation is equal to standard deviation divided by arithmetic mean x bar. These are our required formula for solution of all these measures of dispersion. Standard deviation, variance, and coefficient of variance, variation will be solved with the help of these formula. Now for the calculations and solution of all these three measures, we here make a table. We draw a table for calculation. Here we are drawing a table for calculation of our required question. First one column is for x, 5, 15, 25, 35 and 45, and the last line we make for the sum. Now this column is used for sum of all values. Second column is of frequency. 5 corresponding frequency is 10, 15 the corresponding frequency is 25, 25 the corresponding frequency is 30, 35 the corresponding frequency is 20, and 45 the corresponding frequency is 15. The sum of frequencies summation f is equal to 5, 5, 10, 0, 1, 2, 2 and 2, 4, 4 and 3, 7, 8, 9, 10. So the sum of the frequencies is 100. Now fx, the product of x and its corresponding frequencies. 5 tens are 50. 15 multiplied by 25 is 375. 25 multiplied by 30, that is 750. 35 multiplied by 20, that is 700. And 45 multiplied by 15, 675. The sum of f of x is equal to 0, 6 and 7, 13, 5, 18, 18 and 7, 25. 5, 2, 2 plus 3, 5, 5 plus 7, 12 plus 7, 19 plus 6, 25. So the sum of f of x is 2550. Now we solve first of all arithmetic mean. X bar is equal to sum of fi xi divided by n is equal to sum of fi xi, which is 2550. The formula for arithmetic mean x bar is equal to sum of fi xi by n. Sum of fi xi mean the sum of the product of x and its corresponding frequency, which is 2550, 2550 by n. N mean sum of the frequencies in group data and ungrouped data numbers of observation. So here the number of total number of frequency, which is 100. When we divide 2550 by the 100, then it becomes 25.5, which is our arithmetic mean x bar. Now we make another column here, xi minus x bar. Xi 5 minus x bar 25.5 is equal to 20.5. Next 15 minus 25.5 is equal to 10.5. 25 minus 25.5 is equal to 0. Minus 0.5. Next 35 minus 25.5 is equal to 9.5. And last one is 45 minus 25.5 is equal to 19.5. Here we have no need of the sum of x minus x bar. So leave it and move towards the x I or x minus x bar whole का square. It's mean here we take the square of x minus x bar, which is the square of 20.5 का the square of 20.5, which is equal to 420.5. xi minus x bar square mean 10.5 square of 10.5, which is equal to 110.25. Minus here 20.5 whole square minus 25 point minus 10.5. Now minus 0.5 square minus 0.5 square is equal to 0.25. Minus multiplied by minus is become plus. Negative value multiply by each other, then it become positive. Negativity will be finished. And now the square of 9.5, which is equal to 90.25, and last one is the square of 19.5, which is equal to 380.25. Now here we also no need of the sum of the xi minus x bar square, and we move ahead to f into x minus x bar whole square. Xi minus x bar square is here. Now we multiply all these values with their corresponding frequencies. It's mean minus, it's mean 4420.5 multiplied by 10 is equal to 4202.5. The next 110.25 multiplied by its corresponding value, which is 25, is equal to 2756.25. Now 0.25 multiplied by its corresponding value, which is 30, is equal to 7.5. Now next 90.25 multiplied by its corresponding frequency, which is 20, is equal to 1805. Next value x minus x bar whole square is 380.25 multiplied by its corresponding value, which is 15, is equal to 5703.75. Now here we need the sum of all these value in the last row. Here sum of fi into xi minus x bar whole square is equal to Sum of the all these value mean summation f into xi minus x bar square is 14,475. Now we put all these values in second formula. Now that is standard deviation is equal to positive under root of variance mean summation fi into xi minus x bar whole square divided by n. Now we put the values in this formula. Summation fi into xi minus x bar whole square. The values which we have already calculated is 14,475. The positive under root of 14,475 divided by n. Here we also again describe that n means the summation of frequencies, which is 100 here. Now standard deviation 14,475 by 100 under root, it's become 144.75 under root 144.7%. When we remove the under root, then it's become 12.03. 12.03 is our standard deviation. Now here we have solved the second part of our question, which is concerned with the calculation of standard deviation. Now we move toward the third part of our question. Third part of our question, which is calculation of coefficient of variation. Coefficient of variation is equal to ST, means standard deviation, by the arithmetic mean. X bar mean arithmetic mean. Standard deviation which we have already calculated, which is 12.03, and we have already calculated the arithmetic mean, which is 25.5. Now we divide the 12.03 by the 25.5, which is arithmetic mean. When we divide the standard deviation by the arithmetic mean, then we get the values of the coefficient of variation, which is 47.18. Now the coefficient